So it first says to estimate the limit of this function as x approaches 3. So as x approaches 3, the limit is 4. I already calculated that. Then it says define epsilon equals 0.5. So since our limit's 4, you do 0.5 above and 0.5 below, and then those are your bands, error bands, or whatever you want to call them, and then that's the region that they're at. Then define the limit plus epsilon and the limit minus epsilon. You're going to take where these like intersect basically. And then this was estimated to be 0.8, and then this one was estimated to be 3.25. So then we're supposed to do that on our calculator now. So I already did all this, but you just graph the function right here. And then you put in your band, 0.35 and 3.5 and 4.5, and then to find the intersection you do analyze graph, intersection, and then it'll have you pick the graphs and then do the lower bound and upper bound. So then the actual intersection, the non-estimated one, is 0.7753 and 3.2614. So then we have to determine delta function algebraically. I already did that as well. So you take the the limit plus epsilon and limit minus epsilon values that we found before, and you plug the limit plus epsilon into this one, or you set it equal to this one, and then the limit minus epsilon equal to this one. So that's what I did here, and since it's a quadratic, I subtracted this onto this side to get it set to 0, so I can plug it into the quadratic formula, and I plugged all that in, and then that ends up equaling 4.0554, or then we have our two values, and the one that's furthest away from 3 is this one, so that is our delta function, 4.0554. Okay, and then limits are important to calculus because they're used for so much stuff. They're used for derivatives, continuity stuff, integrals, and they're just used a lot. And a limit is as x approaches c, so like as x approaches a certain number, the limit of that function at that number. So that's what we found initially. And that's it. So we calculated our two values, and the one closest to 3 is our delta function. So this one, 3.3996. And then limits are important because they're used in calculus. They're used for, they're used a lot in calculus. They're used for derivatives, continuity stuff, integrals, stuff like that. And then the definition of a limit is as x is approaching c, and the number that it is. That makes sense.